All right. Hello, everybody.
Hi.
I'm Priyanka. I'm a customer engineer here at Google. You have seen me before. And here is...
I'm Jay Smith. I'm also a customer engineer here at Google.
Great. Okay, and we are joined today by Josh Cogan, who is a software engineer on our machine learning team. So Josh, do you want to introduce yourself and then tell us a little bit about yourself, your background, and then maybe something about our topic today?
Sure. Thanks so much. So I'm Josh Cogan. I'm a software engineer here in the Google Cloud product area. I work on a product called AutoML. We had a really exciting launch a couple weeks ago, or gosh, maybe even months ago to now. Time flies.
Yeah.
And here today, I want to talk about actually something like kind of almost like totally separate. So like hold on to your hats. I want to talk a lot about like the intersection between like business and ML. So, I'm going to start off like a super rudimentary like definition of ML, and then we're actually not going to worry about any statistics, any software packages. We're going to drop all of that. We're really going to think about like some core like topics that like you might have as like a business owner or operator, or like if you took an MBA.
Yeah.
No stats required, no programming required. It's just a topic that I'm really passionate about.
That's great, because I talk to a lot of customers who are really struggling to, connect the business dots for machine learning with the technical dots, and there is a huge disconnect that I see. So I think hopefully to our viewers today, this will be an amazing conversation. Okay, awesome. So do you want to tell us a little bit about your background, where you came from, how you got into this?
So I think, Priyanka, I have a very similar story where like I've had the opportunity to work with a lot of different customers, and I've seen some of the struggles they've hit. So let's see, before I joined Google, I was a management consultant at McKinsey & Company, where I got to meet a lot of different customers who were in very different points along the technology adoption trajectory. And, everybody knows that like ML and automation's the place they got to get eventually.
Right.
But that's a very nebulous, dark path through Mirkwood, right?
Yeah.
Like, who knows how that actually happens, right? And we all have been in those rooms where management's like, you got to innovate. And then like, you're the individual contributor at the bottom, and you're like, what the heck actually happens now?
Exactly.
And so I got to do that a lot at McKinsey, and then I joined Google. And I've had the opportunity to be kind of involved with a team called the Advanced Solutions Lab. And what they do is they kind of do some education, some professional services here at Google for external customers, especially in ML. And so I got to meet a lot of those students and hear their stories. And there's some very clear like common themes that we're carrying in many of our partner organizations.
Okay, so that's how this talk also came about, I guess. Okay,
Absolutely.
Awesome. We are really excited to hear this. So let's dive in.
Great. Let's do it. Great. So, that we chose the title to talk Making Money with ML. You could also kind of think of this as like, when the rubber hits the road, what really happens inside org. So what's really a great way to think about ML other than just another statistical software package. So today, my like kind of like almost naive, but not overly complicated definition of ML is maybe some process of one computer writing a program for another computer to accomplish some task, right? And that seems like really obvious, and perhaps I apologize. What's interesting about this is the computer figures out the best program to write only by looking at a set of examples. And one of the reasons that I like to show this example is these cute diagrams down at the bottom is just to give us a sense of actually how little we need to know, or like about like necessarily like how ML works. Really, the only key thing going on here is it's about the data, right? And we're going to see that over and over again, that people want to do ML because they don't want to code.
Right.
That's only good if you've got great data. If you want to get rid of great code, you need great data. And I think that sometimes this diagram just starts to elucidate that theme that's going to start coming up. That if you lose the programmer, you have to trade in lots of examples.
Right. Is this also how Google thought of AutoML in general?
Oh, interesting. So what AutoML is about is that there's a lot of like kind of unpleasant parts of building great ML systems. And we saw that our customers were really struggling with a lot of common, they were sharing these unpleasant parts. And AutoML's, in its first pass is primarily about automating away that unpleasantry, right? So that we allow customers to think only about the data, and we handle everything else for them.
Yeah. So I don't know, Jay, if you've seen or played around with AutoML so far. I have a little bit with one of my customers, and one of the great experience about that is neither my customer nor me had expertise in machine learning, and we were able to build a custom model just by uploading the images. And we had to make sure that the data is labeled, but we also offer that service through ML. But we were using a really small data set, so we were able to get it up and running, and a model designed in less than like 15-20 minutes.
Oh, absolutely.
I'm sure you've seen actual like TensorFlow models that are used for machine learning, and to the layperson, it's not friendly at all.
Absolutely,
So,
absolutely.
you know, so the AutoML, even the most new person to the concept of machine learning, it seems like, can figure that out, because it's feeding data, it's feeding pictures, it's feeding something that you
We
probably
try and make it very accessible, very visual. You know, it seems to be generating a lot of customer excitement these days.
Exactly. Not to derail anything.
No,
right?
not
I
at
was
all.
just curious. Yeah.
Absolutely, yeah. And the product motivation for AutoML maybe come up on some future slides as well, as we start to weave a story here about how some things are new about ML, and so we are in a little bit of a brave new world, but actually a lot of things are the same, right?
Yeah.
ML is still mostly software, so great ML is mostly great software.
Yeah.
And to that point, so I've had the opportunity to chat with just a ton of different, let's say ML practitioners. Some of them newbies, some of them are veterans. And one of the things one of the intuitions I've seen shared among many newbies is like this idea of like kind of roughly how you spend your time when you're building ML. And this is a super informal data I've collected just by chit-chatting people over the water cooler, right? So let's, put the error bars on the plot here, right? So I find that like when I talk to different customers or practitioners, this is like roughly how they think they're going to spend their time when they're going to build a really great ML system. They think that the lion's share of the effort is going to be in optimizing the ML algorithm. They're going to go read papers, they're going to play with TensorFlow, they're going to sit on their laptop a bunch and just try different things, look at plots, think about them. And then kind of everything else, like, figuring out what you're supposed to build or how you're going to get the data or how you're going to serve this at scale, like all these things kind of get pushed to the side because we're so focused on what's that right algorithm.
Right.
And then I go and I think, I just built AutoML, like with a team of people, of course. What actually happened? And it's a very different plot. It's a very different plot. We find that actually we spend much less of our effort optimizing the ML algorithm than we kind of expected to. And I find this to be true across just a variety of Google teams. And what makes great, successful ML products is not nearly as much about that great ML algorithm as you think. It's a lot more about great data, great infrastructure. And I think this is one of the things that's really allowed Google to be so successful in this industry is that we have, let's say we have like an ML algorithm, we can get it in front of a billion people at scale and safe and secure that infrastructure.
Yeah.
And what made that algorithm so great is we had just some phenomenal insights into what our users were looking for in the first place.
Right. Well, this is very intriguing. I would always think that people are spending a lot more time on the later parts in the algorithm and in the integrations and all that, but reality is different.
Absolutely, absolutely. I like to think about like the Google Maps app.
Yeah.
Right. We think that like the kernel of its intelligence is like how do you route from point A to point B, and that probably is like one of the kernels. But think about how big their web front end team would be alone, right? Like how much infrastructure they need. And yeah, I'm sure there's a team of people that work on optimizing the route finding. I actually don't work with the Google Maps team. But then just the teams, the multitude of teams that have to get all the data in and out, have to keep up all the mobile apps. I mean, it must be phenomenal.
Yeah. Well, awesome.
Yeah. So the funny thing is, so why are we so excited about ML if we kind of are saying that like ML is not even the key component? And I think that ML is really a great long-term trajectory for almost everyone, almost every business process. Because as you progress towards ML, even if you're not there yet, even if you don't get all the way there, most of the impact comes along the way, and it's really an extremely fruitful journey as you continue to get closer and closer to ML. And
so tell us a little bit about like how Google does this. Can we share like the secret sauce? What's Google's practices and best practices?
Yeah. So Google tends to assume that, in my experience with Google, that every product eventually ends in ML. And that no product should necessarily start with ML, which sounds really crazy, right? But I'm actually going to use, let me see, I'll use an example of AutoML, right? So you think like AutoML, it's got to end in ML. We agree, it's in the name.
Right.
But when we're thinking about this new product, we don't start by saying we're going to auto learn, collect all this data, learn everything. What we do is we start with a pilot, right? And so we say like, I've got this idea. We talk about it with other engineers. You know, we let some other Googlers kind of like poo-poo or, you know, your idea, you know, you want some real feedback. And then we go out and we work with some customers. And we started at a very small scale, right? And then actually the first version of this was a little embarrassing. I was new to the company. I was relatively junior. I was the server actually, right? So the customer would email me, say what they wanted. I would go do it. I would email back. Right. And that's how we kind of like figured out roughly like what the right APIs were and like how we wanted it to behave. And then we got successful and we needed to scale. So then what happened is then we started bringing in a few other humans to mock out the server. And that's actually a really important step that I kind of call, I think like the delegation step, where you need to start to formalize the rules of the interaction so that like, you know, if I can tell, you know, Priyanka, like, hey, here's what you need to do to accomplish this task, then we started to set down the rules. And then we started to actually build the server. And I call that kind of, I think of that as like a digitization phase where like you're starting to actually, that's the core automation of the humans. And then as you progress and you start to serve many, many people, maybe you get into something of like a big data phase where like now you're serving so many people that you can start to understand their behavior. You have whole new insights. You're no longer like kind of relying on like your PMs or your marketing team to do research. You're like, we just have the numbers. We really know what customers want. And then you can start to optimize the experience around that. And then finally, when you think about like ML, I think about, you know, taking all that data you've been collecting, like automatically feeding it back so that your product itself is actually automatically acting on these new insights.
Got it. Okay. So when does ML skills come into picture in the entire process?
That's a great question. I mean, I think one of the reasons I love to teach ML is that like you need to know kind of how ML will play out to start in the right angle, right? And I think that like you have to get your hands dirty with some real ML skills to be great strategists. And because you have to be, I find like a true defensiveness about data. Like you kind of fear the data, kind of love the data. It's a very complex relationship. And so definitely in the beginning, but you know, ML skills only become like highly critical once you've collected that data, or once that data is coming in, you need someone to help you think about what the right data is to collect. You kind of go from like maybe like a little bit of data scientist into like ML algorithm builder, which are both skills that are often associated with other like software stack skills.
Right. And why would one want to necessarily start building these skills, would you say?
So I think ML skills are really interesting because we look at like kind of like the long-term trajectory of the software industry. We find that it's getting cheaper and cheaper to collect more data, and human labor costs, you know, are always increasing. And so we're kind of changing the balance here of like, how much should a human think through every possible corner case versus just telling the computer, hey, I've got all this data, you please think through all the corner cases. That's roughly how I think about the balance of power here.
Okay, nice.
Awesome. So let's dive into your 10 pitfalls.
Wow. So I have this kind of like very purposely clickbaity title here about the 10 pitfalls. Most organizations I feel like don't even see coming. They get so excited about ML, they try to jump all the way to the end, and sometimes there's some tripping involved. I think this is actually one of the most common ones. An organization thinks that training their own ML algorithm will be faster than writing the software. They're like, oh, you know, I can't figure out all the corner cases. I'm just going to auto learn everything, right? And this is really interesting because I like to, you know, I believe that every problem has a certain like irreducible complexity, right? You can always have a worse solution, but there is some best solution. You can't get any less complex than that. And the problem is when you use ML, you just move all that complexity into the data. So you can't say, oh, I'm sure my data is right. let's just put our business into its hands. You have to have people who are really vetting that whole process, right? And so when we write software, we have a little bit more control, but a little less scalability. And then as we move to ML, we release some of that control, but in an effort to scale to more insights and more features. But it's definitely not as fast. Like next one, you haven't collected all the data yet. I mean, I know it sounds so naive to say, but I have so many people really excited to do ML with no long-term plan of how to collect data, or even if they have the data yet. And then the next one is kind of same vein. It's super organizational. Like maybe Priyanka and I work in different organizations, and her org has been collecting the data. And Priyanka says, "Josh, the data's ready."
Yeah.
Right? I'm like, Priyanka, does anyone in your org like look at that data regularly? Like, no, but I know what's going into the database. I promise you, it's not ready. It's never quite there.
Yeah.
This is one I see that like Google and some of the other large companies intuitively know, this next one, but I find a lot of startups skip that. You have to put and keep humans in the loop, right? People who are going to be constantly labeling new data, evaluating data, right? So like we all know like Google's search algorithm and ads algorithms are huge ML, juggernauts.
Right.
We often don't talk about there are some human reviewers in there, right? And like there really need to be. Otherwise, maybe you have like search, believe it or not, it's kind of an adversarial system where people are trying to always move, shift different types of results up and down. And when Google will use a team of humans to always be double checking, some small fraction is getting served correctly.
Just like the previous point you had there, which is assume that data is ready. It's just, combining those two together, even though you're collecting the data, it doesn't mean that it's ready. You need some human eyes, you need labeling.
That's right.
Some automated way of either labeling or a human looking at it, checking it.
That's right.
That's
right. Absolutely.
Great point.
Absolutely. I'm going to skip a few. I think that one of the things that's interesting is like this idea that if you wanted to launch an ML first product, which is like, hey, I've got this great idea. Its great idea is it's ML. It's going to be really tough because you don't yet have the data, because you don't yet have the customers.
Right.
But also you don't have any measurement if your ML is helping or not, right? And so like I often think about like, hey, let's launch the naive thing first. Let's get people excited. Let's fill out our core value prop to customers. Is rarely we did it with ML. It's usually we did something you wanted, even if we didn't do it in a cool way.
Yeah.
Right.
And then when we flip on the ML in the background, we can see that uplift, and that really helps conversations with management understand, their own investment strategy of like, how many people do I put where and what.
So the recommendation is solve for the use case. Don't start with ML in mind. Solve for the use case and follow it up and make it better with ML over time.
I completely agree. I'm thinking about like Facebook, right? Like Facebook's initially was like there was no ML, right? If I like way back in like 2004 or whatever.
Yeah.
There are always these static pages, and then they had a great platform, and then then they could start thinking about how do we link these users together.
Right. All the big products, right? Even search, maps.
Absolutely.
They all start with a use case, and then you
do that well.
ML.
Photos, a lot of products out there.
Yeah. Great. Okay. So do you want to move to the next?
Yeah. Let me just talk about one or two more.
Okay.
I find that a lot of practitioners also have this idea that like, hey, they're gonna design and build an algorithm, they're going to compile it, if you will, and it's going to be done. And we find that at Google, everything has a giant pipeline because everything that we train will be trained again and again and again and again and again. And then like the idea of like once it's on your laptop, it's done. Totally not true.
Right.
That like once it's on your laptop, it's ready to talk to someone else. But like you're not done. Right. And then I'd say the final mistake I see, kind of maybe not mistake, misconception I see repeated a lot, is that you want to design your own in-house perception or natural language processing algorithm. What's interesting about these two specific classes of ML is that they are highly optimized and have a very long academic history. And so it can be very hard to beat to achieve better performance than something, a cloud provider or another service provider would have, because they are, they're large teams supporting these types of things already.
So it sounds like going through all this list, training a machine is very similar to training a human, like a child. You feed it a lot of information. You have to keep reinforcing that information as times change, as it goes out into the real world. You're having to adjust all that. I mean, it sounds very similar, but in its own way different, since machines don't necessarily have the same brain as a human. So maybe a little more effort put into it.
Interesting. I mean, that's a really interesting corollary between like children and machine learning algorithms, because in some ways they both start with like tabula rasa, like they truly don't know anything. And I think that's usually one of the common mistakes people go through when training their first ML algorithm, is they assume that what's obvious to them is obvious to the machine,
Mhm.
but they wouldn't treat a child like that, right? Like, a child like picks up a phone and drops it because the child does not know the phone will drop. The child just has to drop the phone a bunch of times to
Mhm.
believe that it will drop the 10th time, right?
Yeah.
Right.
And I think it's true for the algorithm as well. It's like it doesn't know anything, which really provides this great learning opportunity.
Mhm.
Yeah.
Okay.
Yeah.
So we mentioned this a little bit a couple minutes ago. I kind of think about like the path to ML. It's kind of like these like 5 phases. And we talked about like, there's one person who's an individual contributor, and then we delegate and so on and so forth. And so on the top here, I have these kind of 5 phases, and then down along the y-axis, if you will, I'm gonna have some like different characteristics that will help us understand how each of these phases are a little bit different. And I really encourage every org to see each of their products someplace along this trajectory or working its way to the trajectory. Now, not every product really has to end in machine learning. There are probably some things you're like, look, we serve 5 customers with this. Like we're signing contracts, we're a legal team. Like, what do you mean ML? Like that's fine. I think ML may be the right answer in the 50-year horizon, but maybe not the right answer for every product in the 5-month horizon.
Right.
And so let's control our expectations. So one of the things that's changing is like who executes this core process. Like if you have a business process and all business processes must evolve, who's executing it? So we have an individual contributor, there's one person. When we delegate, we have a team of people. And then when we get to digitization, big data, machine learning, all of these are actually being executed in the same way with the computer. And we should remember that like most of the benefit comes just by automating the core task in digitization, right? So like it's super important that we get from individual contributor to digitization. And then the other ones actually have kind of, I would say, like a little bit of almost diminishing returns. Like I think sometimes people risk all or nothing. And I like to remind them that there's a lot of value with each of these steps.
Okay. So does that mean the individual contributors who are also working on digitization?
So that's how it works at Google and probably a lot of other like tech companies, is that like you have someone who is thinking, I'm going to digitize this.
Right.
But first I want to learn a lot about the process itself. And so they do it themselves. Like, so when I was serving my pilot customers and I would pretend like I was the server, I was like in my head thinking about what are the APIs I need to build.
Right.
But at other companies, that might not be the case, right? Maybe you have someone who answers the phone.
Yeah.
Then you need to scale them. You have many people who answer the phones. Then you build a call center, and then you automate that. So it need not be that way.
Okay. Well, thanks for the clarification.
No problem. And then I think about like the next way in which these can all be different are how are the operational parameters chosen? And so we think about like a piece of software. We often think about just like a monolithic block of code. But actually this like block of code usually has a couple of configurational operational parameters in it. Like, let's say we have a call center example, like, how long do you pause between each sentence, right? That's an operational parameter. It's probably not hard coded in. You can probably tweak it a little bit. And so what happens from kind of the individual contributor phase up through digitization is you have someone kind of doing very manual research, right? You have like a product manager calling customers, trying to figure out what the right things are, or the right choices are here. Or you have like, Gartner's market research or something like that. Then what happens when we get to big data is for the first time, we, the operators of that process, have so much data either from internal users or external users that we can actually go and look and say like, well, what do those different operational parameters affect? How do they affect them? We can see, on like that Google search page, what's the ideal color of blue? Because we could just run a bunch of tests and see what the ideal color of blue is.
Yeah.
And then what happens when we get to machine learning is not only do we have all that great data, but we may start to automatically fit and act on it as well. And then the final one is once you had these parameters, these new operation parameters, how do you feed them back into execution? And so as long as you have humans who are executing the process either through individual contributors or delegation, those new parameters basically have to go into like some kind of HR training manual or something like that. It can be a very slow, very actually lossy communication channel where this is why you think about like huge HR training orgs and you have to constantly feed information in people's heads.
Right.
And then when we get to kind of digitization and big data, basically someone tells a programmer, the programmer puts it in.
Yeah.
And then when we get to machine learning, what's really magically happening here is these new operation parameters are automatically being fed in, in a probably very high throughput, high fidelity fashion, right back into the computer program.
Okay. So I have a question, and maybe this is not related to the 5 phases, but I talk to customers about like automating frequently asked questions or like HR manual you brought up, and they would like to automate that into like using some of our other products like Dialogflow and natural language APIs. That is a product of all of this process, or would it be
like walk you through that story maybe?
Right.
Yeah. So I think that's really interesting. So like let's like look at the slide and think about, we operate like a website, like we're Bank of Priyanka, and we operate a website, and we get customers call us every day asking the exact same question. Right. Okay. So you're probably someplace in the delegation phase where you have someone answering that call center, right? Or maybe that was like 2005, 2015. Later, all of those phone calls were answered by computers, and now you're in the digitization phase. But what you'd really like to do is you'd like to kind of tweak your menu so that the most commonly asked questions are like right at the top of the menu, or they're on the website. And that to me is actually, I would say that's what the big data phase starts to look like, where you've got all these call logs, because they ask you if they can record you. And you're looking to and then you try to organize these questions to see what the top ones are. And then you try to answer them in a new special way so the customers aren't even calling you in the first place.
Yeah.
And then maybe what happens with machine learning, like a product like Dialogflow, is you give Dialogflow a lot of examples of what the likely questions and answers are, and you just let the machine answer them directly for you.
Yeah. So again, I think we kind of went back to your starting point, right? Where you said, start with the problem, see how that goes. Now collect the data about what's going on with the use case, and then go back and train the model and start to build. So you have to here also in this example, you have to first build like, what is that flow going to look like without ML, without anything for a customer? How do I want to, what do I want to offer as options? And then see how that goes, tweak it as it goes using big data and all that, and then apply machine learning to it. So we kind of brought it full circle with this use case. Awesome. Okay.
And then, so I guess my final reminder for you guys of this little bit of like a humorous slide, hopefully it's not too tongue-in-cheek for you, is that I know we all want to jump to the final, fully automated, automagic ML solution. I just want you to know it's a risky move, and I've seen it hit a lot of obstacles in partner organizations. And I find that success typically follows kind of a more structured approach, where we steadily increase the upfront investment as we do more research and as the business uncertainties decrease. And when we think about, how business processes operate and evolve, which I have kind of like a little diagram down here on the left, what we're basically trying to do is we're trying to fully automate the business process diagram. So everything from the core process to how we generate new insights to how we tune the process itself. We really just want to reach out, we always want to be thinking, how can we better automate?
Right. Yeah. Awesome. So do we have any more questions on the channel?
Yes, we actually have just the one question here. And let me see. Let me pull it up. Let's read it right off the channel. So, could you enlighten us on how to collect data quickly and inexpensively? For example, an image description combination.
So I think that like in general, I would put data sources into like two different categories, which is either like open source, like maybe it's like an academic data set, and those can be great to kind of quick proof of concepts or demos. And then those there's giant lists of them on some website and stuff like that. But perhaps the more interesting or challenging question is like things that your startup or your company uniquely has access to that other people don't, because then we're starting to look at like, real unique competitive advantages for startups. And I think that, so images are interesting because they're fairly heavy and they usually have some interesting licensing rights around them. But things like click-throughs and stuff like that, there's a variety of services that help, like Google Analytics can help you track and like de-anonymize that, so you can figure out what's working for your customers without, necessarily being, while still respecting their privacy at the same time.
Okay.
And I think that like automated data collection is, a huge step in that direction.
All right.
Great. Okay. So, well, is that all the questions we had? Okay, great. We do have an offer for our viewers today. And the offer is, I'm going to bring it up and we'll put the link in the slide as well, on the chat as well. All right, so Jay here is going to put the offer link in the chat window so you can utilize that offer, which is really for our cloud startup program. You can get to the link through g.co/cloud startups to understand what the eligibility is, and we offer about $3,000 in credit for eligible startups, and offer is valid till April 12th to enroll. So go do that, and if you are watching this not live but later, then come back to our online meetup next time, and you'll get another offer to utilize that. So with that, I think if there's no other questions, we can close that out.
So,
Thank you.
Thank you.
all right.